Okay everyone, in this recording I will talk about the equation of motion when we have a rotation. So in the previous cases, if you remember, we talked about equation of motion in a translation case, but now it is equation of motion in a rotation. So in the rotational case, we don't have anything different other than the Newton's second law in curvilinear coordinates, and also the last thing is that the moments about any point is not equal to 0, and this one is about g, and this one is about pin O. Okay, these are the equations. Now let's see the general picture. What happens? We have an object, and this object is under external forces of F1, F2, F3, and then F4, and each of them has different directions and magnitudes. And then in addition we have M1 and then M2. And this M1 and M2 gives a rotational acceleration of alpha and then velocity of omega. If you come back here, you see we have the moments, but it doesn't create an acceleration. But here, similar, but here we have an acceleration about point G. And this point G is the mass center, and it has a curvilinear path with a tangential acceleration and normal acceleration. In addition to that, from O to G, we have the position vector of R of G. Okay, this is the general image that what we may have, and this is just a force free body diagram. And then if you are interested in any point that is neither pin, okay, nor the G. G is the mass center. Okay, then you have to use this equation, which is the vector equation. Okay, or scalar form of it. Okay. Scalar form, but you have to know that the counterclockwise direction chosen as positive. Okay, that is how we are going to solve the equations. These are the equations for a motion for the rotation, but when we apply it for this kind of problems, and then you will see how it is. I mean, how do we use it in practical cases.